Okay, let's go on with the definition. The next definition is the order of the group. Does anyone know what's the highest civilian award in Canada is called? Canadian government gives out. It's called Order of Canada. So it's like Canada is a group. Okay, so sorry, that's a bad joke. So if G is a finite group, then the number of elements of G is called the order of the group. And I think it's written like G or something, mod of G. Okay, so this was a very quick definition. The next definition is more interesting. We are going to define a coset. So what is a coset? So let G be a group. So see that we are no longer writing G comma this, so that the multiplication is implied, okay? So G is a set, but we are implying that there's a multiplication, okay? So let G be a group and H be a subgroup. We're not saying anything about whether it's a proper or improper subgroup. Okay, so for now, although later we will relax this condition, for now, for the sake of definiteness, let us take G and H to be finite. Okay. Now let H be the subgroup. Let's call its elements say H1, H2 dot dot H M. Okay. So since this is a group, that means that E is a part of H, right? So this is a parenthetical remark. Now, let G be an element in big G. Then the left coset of the subgroup H in G with respect to the element G is defined to be the set GH, and that set consists of all the elements of H, but left multiplied by G. Okay, so this is called the left coset of H with respect to G, small element G, okay? So one quick comment is that you can verify easily that if you take, just one second. Right. So comment number one is if you pick G to be an element in the subgroup H itself, then the coset that you construct, GH, is actually equal to, of course, HH, which is, of course, H. So in that case, the coset is the subgroup. Okay, so that's comment number one. Number two is that analogously, one can define the right coset. As HG, H1G, H2G, dot, dot, HMG. Okay. Now, the left coset or the right coset, do not form a group. In general, there might be some case where they do. Okay. All right, so I'm going to end with a very exercise of a theorem that I want you to try to prove. It's okay if you can't do it, but if you don't try, you don't learn. And the exercise is prove Lagrange's theorem. Don't look it up, try to prove it yourself, because you'll have to submit it and someone will. Because there's no marks, okay? I'm not going to give out any marks for this. The whole point is, why am I using red? I'm not going to use red, I'm just going to use gray here. Okay, Lagrange's theorem. And what does it say? Let G be a finite group of order, say n, and H be a subgroup of order m. So then show that m divides n. That is, m divides n, that is, k is a positive non-zero integer. Okay, so this notation means that m divides n. Okay, so that means that if a group admits a non-trivial subgroup, a proper subgroup, that it cannot be a prime number, right? You see that? So this is Lagrange's theorem, and this is also an exercise. So that brings us to the end of this class. Now, before I take the attendance, are there any quick questions? Or maybe I should take the attendance and then take questions, because some people have to go, right? So let's take the attendance. Rahul, are you there?
Yes, sir.
Okay. Ahmed Zabir Hussain. Dipro.
Yes, sir.
Okay, that's Tibra. Okay. Medad,
Present, sir.
Yashan,
Present, sir.
okay. Shujosh,
Yes, sir.
Sitima.
Present, sir.
Good. Audrey was there. I noticed Saif is there, right?
Yes,
Present.
Okay. Mohammed Abdullah.
Yes, sir.
Now he is there. Umme Fatima Fiza.
Here, sir.
Okay. Fine Firdaus.
Yes, sir. I'm here.
Okay. Farhan.
Yes, sir.
Okay. Ushik Hassan. No Ushik Hassan. Okay. And Proma is there. I saw that. Okay. All right. So that was those are the people who registered for this course. So yeah, let's have some questions. But you guys are free to leave if you have to, because the class is formally over.
Sir, could you explain the coset again? I didn't quite understand.
Right. So the coset is, suppose you have a group, say G. So this is some set, which is, and you have some subgroup, say H. Okay. Now, if it's a subgroup, that means that it has the element in it, the identity element, right? Now, suppose you take some element from here, say call it G, and it's not part of the subgroup. We'll explore what happens when it's part of the subgroup. And then what you do is that you take G and take every element of H and you multiply it with G. Suppose H has M element. So you get a new set with M elements. Okay? So, sorry. So this new set we are calling small g, big H. So this is the coset GH. Okay? That's it. So the other thing is that if you chose for G an element H from the subgroup, then what would happen? Then you're looking at HH. So you get HH1, HH2 dot 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 HHM. But since H is a group, it's closed. So this is going to give you some other element in H1. And this is going to give you another element in H, let's call it H2 prime. And similarly, you can show that every element is going to be different element, but it's good, but closure tells you that it's going to be part of H. So it's obvious to see that this is closed, but what is not obvious is that all these new elements are just a reshuffling of the old elements in H. That, they're unique. All the elements are unique. Okay? So that means
H
that,
is a subgroup.
sorry? Yeah.
So H is a subgroup.
This is a subgroup, yeah. So that means that this is equals to H. So the coset construction gives you a new set, but it gives you the same group if for the element G, you took an element from the subgroup itself. That was a comment. Okay, so I explained what the coset is, and I also explained what the comment was.
So is the coset, is that a set or a new group?
It's a set. It's not necessarily a group.
Okay, got it.
But if G is outside from the subgroup, it's a set. It's not closed under multiplication. So for example, if you take G, which is not in H, then G times E is going to give you G. So you see that automatically you are, the resulting element is no longer in H. Right? And there's no guarantee that that will actually be part of a group then.
Oh, okay, sir, got it.
Okay, any more questions?